Hello students, in this video I am going to discuss about the practical information of KCL, that is Kirchhoff's current law. Let us start. So first of all, this is the circuit diagram that we are going to design on the breadboard. It will have total 5 resistances termed as R1, R2, R3, R4 and R5. So these are the resistances. The value of all these 5 resistances will be taken as 1 kilo ohm. After that, the input voltage that will be provided with the help of power supply, here it will have the value 5 volt. Okay, so this is the arrangement, the combination of series and parallel of 5 resistances R1, R2, R3, R4 and R5. And then we will try to calculate the Kirchhoff's current law at different nodes. So these are the nodes A, B, C, D and E. So we have all these nodes available with us. So what do you understand by Kirchhoff's current law? It states that the algebraic sum of all the currents at any node is equal to 0. So let us apply KCL on all the nodes that we have. And how to write down the equations with the help of KCL, you can consider my previous videos in which I have explained how to write down the equations for KVL as well as KCL. So the first node A, minus IS plus I1 is equal to 0. Node B, minus I1 plus I2 plus I3 is equal to 0. Node C, minus I3 plus I4 is equal to 0. And node D, minus I2 minus I4 plus I5 is equal to 0. Where I1, I2, I3, I4 and I5 are the currents flowing through R1, R2, R3, R4 and R5 respectively, and IS is the total current which is flowing in our circuit and which has started flowing from Vs, that is the input voltage supply. So now let us discuss the ammeter connections. As you know that ammeter is going to be used for the measurement of current. And here we will be using milliammeter for that, because the value of current which we are supposed to measure over here will come under the range of milliampere. And ammeters are always connected in series. So we will try to connect ammeter one by one with all the resistances in series, and thus we will try to calculate the current. So let us start with the first current measurement. So as you can see, supply is directly connected with resistance over here. So every time for the ammeter connection, we have to break one connection and then we have to introduce ammeter in series. As you can see, this is now going to be the new connection over here. Now the new connection is positive of supply is connected with positive of ammeter, whereas negative of ammeter is going to be connected with R1, and there is no positive and negative for resistance, hence it can be connected anyway. But this is our new connection. So by connecting such connection of the ammeter, you will be able to calculate I1 flowing through R1. Second is the value of current flowing through R2. Once again, break the connection and introduce ammeter in series with R2. So what is the new connection now? At node B, we have R1, R3 and positive of ammeter and negative of ammeter connected with R2. And do not forget to restore the previous connection. As you can see it over here, I have restored the previous connection by removing the ammeter. The third connection of the ammeter with R3. So here comes the third connection. So in the third connection, I am going to use ammeter over here with R3 in series connection. So now the new connection is at node B, we have R1, R2 and positive of ammeter, and negative of ammeter is connected with the removed connection of R3. Thus we will be able to calculate I3. Next is I4. So the value of I4 will also remain same as we have calculated I3, because you can see it over here. This is just a normal series connection we have. So there is no other branch, hence the same amount of current will be there for I3 as well as I4. And the last one is I5, the current flowing through R5. So either you can connect this way or you can connect it this way, the value will remain same. So I have now removed this connection, ammeter negative here and positive here. Why negative here? Because now negative of ammeter will be connected with the negative of supply and the positive of ammeter will be connected with R5. Hence, we will be able to calculate the value of current I5. Once we have calculated all the values of currents I1, I2, I3, I4 and I5, as already discussed the node equations, we have to substitute all these values in the node equations and hence we can verify Kirchhoff's current law as well practically. Now let us see what about the connections. For the working of KVL, Kirchhoff's voltage law, we are supposed to connect 5 resistances together and all the 5 resistances will have 1 kilo ohm resistance. 1 kilo ohm means brown, black and red. So let us start making the circuit diagram. So this is the first resistance. Here I am first of all making terminal B. What is terminal B? Where R1, R2 and R3 all 3 are connected together. Hence all these 3 connections will be done in a single column. So here we have R1, this one R1, this one R2 and this one is R3. So I have connected R1, R2, R3 all 3 in a single column like this. So R1, R2, R3. Next is R4. So the one terminal of R4 is connected with R3 and the other terminal is connected with R2. Finally R5. So this is the resistance R5 which is going to be connected one terminal with R2, other terminal with power supply. So one terminal I have connected with R2 and the other I am going to connect with power supply. So here I have taken power supply, set it to 5 volt first using channel A. So A must be pressed over here, 5 volt. So initially positive. So positive is connected with the first terminal of R1 and the negative is going to be connected with the other terminal of R5. So this is our connection. Okay, so now I am going to calculate the Kirchhoff's current law and I have taken the same circuit diagram once again. The same combination of R1, R2, R3, R4 and R5. But now I have taken an ammeter instead of voltmeter. The input voltage is also set to 5 volt. Let us first of all calculate the current I1 flowing through R1. As you know that ammeter is always connected in series. Hence we have to break one connection and introduce ammeter in series like this. So I have break one connection and now we are supposed to connect ammeter in series. So the positive of ammeter with the positive of supply and the negative of ammeter with R1. So here comes the value of first current I1, that is equal to 1.8 milliampere. Second I2, but for that remove ammeter and do not forget to restore the previous connection. So I have restored the previous connection. Now let us calculate I2. For I2 we have to remove R2. So I have removed one terminal of R2. In place of the terminal of R2 we are going to connect the positive of ammeter and the negative of ammeter will be connected with the removed R2. So here comes the value of I2, that is 1.2 milliampere. Remove ammeter. Again do not forget to restore the previous connection. Now I am going to remove R3 so as to calculate I3. So I have removed R3. In place of R3 connect positive of ammeter and with the removed R3 connect negative of ammeter. So here comes I3, that comes out to be 0.5 milliampere. R4, for R4 restore the previous connection and remove one terminal of R4. So I have now removed one terminal of R4 so that we can connect ammeter in series. So here comes the positive of ammeter and the negative of ammeter with the removed R4. So that is also comes out to be equal to 0.5 milliampere. restore the previous connection as it is. And now the final one, I5. For I5, remove one terminal and connect ammeter in series, one with one terminal of resistance and the negative with negative of supply. Make sure to connect negative with negative of supply only, otherwise the polarities will change and the result in ammeter will come in negative. Hence I5 comes out to be equal to 1.9 milliampere. So again, by using the node equation, you can insert all these values in the node equations by applying Kirchhoff's current law theoretically, and you will be able to verify Kirchhoff's current law as well.